Welcome to Anduski Lectures. Topic is Thermal Properties of Materials, Ceramics, Polymers, Glass Composites. Teacher Anand Mohandas. Thermal Properties. What happens when a material is heated? Basically, thermal properties of material refer to the response of materials to changes in their temperature and to the application of heat. So, when a material is heated, thermal expansion can happen. So, thermal expansion means the material expands when heated. There can be a change in the area, volume, and shape of the material. Another property is specific heat, then thermal conductivity, melting point, heat capacity, thermal diffusivity. A specific heat is the amount of heat necessary to change the temperature of 1 kilogram of mass by 1 degree Celsius. Thermal conductivity refers to the ability of a given material to conduct transfer heat. And melting point is the temperature of a material where it changes from a solid phase to a liquid phase. Thermal diffusivity, the ratio of our thermal conductivity and heat capacity. Now, cryogenic temperature. Cryogenic temperature range has been defined as from minus 150 degrees Celsius to absolute zero, that is minus 273 degrees Celsius. The temperature at which molecular motion comes as close as theoretically possible to ceasing completely. So, for cryogenic application, the materials normally used are liquid propane, solid carbon dioxide, liquid hydrogen at minus 253 degrees Celsius, liquid helium at minus 270 degrees Celsius. There are thermally insulating materials like fiberglass insulation, mineral wool, cellulose, polystyrene. Now, properties like thermal conductivity, specific heat, linear thermal expansion coefficient, and Young's formulation are taken into account for selecting the material. So, the effect of temperature on materials is studied, and different materials react to the application of heat differently. So, studying that, the properties like thermal conductivity, specific heat, linear thermal expansion, etc. are taken into account for selecting the material. Now let us look at ceramic materials. Ceramics are a class of materials that are made by shaping and molding raw materials and then heating them to high temperatures. This process forms hard, strong and durable materials. So thermal property is high melting point, makes them suitable for storing hot liquid. Other properties are brittle, very hard, do not conduct electricity. Brittle means they are likely to break or shatter under pressure, and very hard makes them useful as building materials. So ceramic are widely useful as building materials. Now, bricks and pottery are ceramics. And there are two examples of ceramics, bricks and pottery. Now, at high temperature, the process forms hard, strong and durable materials that can be used for many purposes. So, ceramics are a class of materials that are made by shaping and molding raw materials and then heating at high temperature. Now let us look at polymers. Polymers are large molecules made up of repeating units known as monomers. These monomers are joined together through chemical reactions to form long chains. An example of polymer is polythene, which is formed by joining many ethane molecules together. Now, thermal property, when you look at it, one of the thermal property, when the polymer is heated, the polymer chains are able to wiggle around each other and the polymer becomes soft and flexible, similar to rubber. This state is called the rubbery state. Physical property is typically solid at room temperature. Electrical conductivity, they are electrical insulators. These polymers do not conduct electricity. And there are natural polymers and synthetic polymers. Natural polymers occur in nature and can be extracted. They are often water-based. Examples are silk, wool, DNA, cellulose, and proteins. Synthetic polymers are derived from petroleum oil and made by scientists and engineers. Example of synthetic polymers include nylon, polyethylene, etc. Now let us look at composites. Composites are materials made from different types of materials. And the properties of an example is a reinforced concrete, and they are strong when compressed and strong when stretched. So composites are materials made from two different types of material. For example, reinforced concrete. It is a mixture of both concrete and steel. Silicon, at room temperature, silicon is relatively inactive element. And being solid, does not combine with oxygen or other moles related elements. Glass is made from natural and abundant raw materials, sand, soda, ash, and limestone that are melted at very high temperature to form a new material, glass. At high temperature, glass is structurally similar to liquids. However, at ambient temperature, it behaves like solids. Glass is an amorphous material. That's important. It's not crystalline based. Pure glass is an amorphous material that lacks a long-range periodic crystalline structure. But glass can be given some treatment to make it crystalline. We'll see that. That is glass ceramic materials. Glass ceramic materials have the same chemical composition as glasses, but different from them that they are typically 98% crystalline by volume with only a small percentage of vitreous. Now properties are high strength, high impact resistance, low coefficient of thermal expansion, good resistance to thermal shock. Now soda-lime silica glasses, borosilicate glasses are examples of glass ceramic material. Borosilicate glass, they have good thermal shock resistance and can withstand extreme thermal cycling with minimal effect. But soda-lime silica glasses are typically not as durable as other glasses, including borosilicate composition. They tend to be prone to thermal shock failure and can degrade in chemically corrosive environment. That is soda-lime silica glass. And soda-lime silica glasses, many of the glass used to create food and beverage containers inside the refrigerator, you can see, and decorative tableware and accessories. And the borosilicate glasses, they have good thermal shock resistance. Thank you for watching the video. Thank you.